G'day team, welcome back to another video. So today we're continuing on our unit circle work, but we're going to do a bit of a deeper dive into the multiples of pi on 4 and pi on 6. So to start with, the multiples of pi on 4 or 45 degrees. So have a look at your unit circle and locate pi on 4. Alright, what quadrant are we in? Hopefully you are in the first quadrant. Alright, we know pi on 4 is less than pi on 2. Alright, and then the next thing I want you guys to look at are what are the cosine and sine values of theta equals pi on 4. Alright, hopefully you guys can see it's either 1 on root 2 and 1 on root 2, or if you have a different unit circle, root 2 on 2 and root 2 on 2. So they are exactly the same, except one has rationalized the denominator. All right, so just back to what we're going here. I've got a few little prompting questions. What are angles AOD, DOC, and COB? I'll give you a quick moment to think about that. Now, hopefully symmetry is sort of kicked in for you and you know that that whole angle, hang on, inside here is actually 90 degrees or pi on 2, and that's the same for all of them. All right, now because we're looking at multiples of pi on 4, if we're converting this to have the same denominator as pi on 4, they're all equal to 2 pi on 4. All right, and that is what we add. All right, so if I have pi on 4 here and we're adding 2 pi on 4, we get 3 pi on 4. If adding another 2 pi on 4 to that, we get 5 pi on 4, and so on until we get to 7 pi on 4. All right, so multiples of pi on 4 will all involve plus or minus 1 on root 2 or plus or minus root 2 on 2. All right, depending on your unit circle and what you're comfortable using. Now, multiples of pi on 6 or 30 degrees. So just a quick little side note, because hopefully you guys have noticed that there is actually a pi on 3 on the unit circle that we haven't talked about. But pi on 3 is actually a multiple of pi on 6. So pi on 6 is equal to 30 degrees. Multiply both sides by 2. So we get 2 pi on 6 equals 60 degrees. 2 divided by 6 is 1 over 3. So pi on 3 is actually 60 degrees, which is our first multiple of pi on 6. Now, the next thing I want to show you is how to get the coordinates for these points. Now, the cool thing about having a 60 degree angle here or a pi on 3 radian angle here is that this perpendicular drop down here is actually a bisector of this radius. So we know that this length here is a half, this length here is 1, and we can find this k length using Pythagoras. So that's actually what I've just gone and done here. So we've got our a squared plus b squared equals c squared. Solving through for k, all right, k squared equals 3 on 4. That means k equals plus or minus root 3 on 2. But because at the moment we're looking in the first quadrant, k is positive, so k is root 3 on 2. So that means p actually has the coordinates a half and root 3 on 2. So just like pi on 4 and multiples of that, all multiples of pi on 6 will involve plus or minus a half and plus or minus root 3 on 2, okay? They might be positive, they might be negative, half might be in the x coordinate, half might be in the y coordinate, and so forth. But each coordinate will have one of each. So, one thing I want you to have a look at is which number is bigger, a half or root 3 on 2? So hopefully intuition sort of kicks in here and you can see that root 3 on 2 is actually in fact bigger than a half. So what I want you to actually look at is what, on your unit circle, what multiples of pi on 6 actually have cosine theta equals plus or minus root 3 on 2? Which values for pi on 6 have the larger cosine value? I'll give you a quick moment just to have a look. Pause the video if you like. So, hopefully you guys have noticed that all of the odd multiples of pi on 6 actually have a cosine of plus or minus root 3 on 2. So this is how we write this. So an odd number is 2 times any number k, so 1, 2, 3, 4, 5. What that does, that creates an even number, and then if we just take one away, that's always going to give us an odd number. So cosine of an odd multiple of pi on 6 will equal plus or minus root 3 on 2, which in turn means the sine of that odd multiple will be plus or minus a half. Then if we're looking at the even case, the cosine of an even multiple of pi on 6, which will probably give you a pi on 3 multiple, is equal to plus or minus a half, and the sine of that even multiple of pi on 6 is plus or minus root 3 on 2. All right, so in summary, multiples of pi on 2 involve 0 and plus or minus 1. All right, so hopefully you guys are all over that fact by now. I know we didn't explicitly go through that today, but you should be all over that. Multiples of pi on 4 involve plus or minus 1 and root 2, and multiples of pi on 6 involve plus or minus 1 on 2 and plus or minus root 3 on 2. All right, so some really key points there. All right, let's do some examples. So find the exact values of cosine 3 pi on 4, sine 3 pi on 4, and tan 3 pi on 4. Just like we did with all the questions in the previous video, we need to determine what quadrant we're in and if our values are going to be positive or negative. So 3 pi on 4 lies between pi on 2 and pi. So that means we're in quadrant 2. Because we're in quadrant 2, our cosine value will be negative, our sine value will be positive, and our tan value will be negative because we've got a positive divided by a negative. All right, they are some really key facts to keep in mind when we solve these questions. So because we've got a multiple of pi on 4, it means we're dealing with plus or minus 1 on root 2. And luckily enough for us, both are 1 on root 2. So because cos is negative, cosine's negative, cosine 3 pi on 4 is negative 1 on root 2. Sine of 3 pi on 4 is positive, and that's 1 on root 2. So that means tan of 3 pi on 4 is negative 1 on root 2 divided by 1 on root 2, which is negative 1. All right. So they're the exact values of cosine 3 pi on 4, sine 3 pi on 4, and tan 3 pi on 4. Now, the second example I want to run through is a little bit trickier. So without your calculator, I want you to evaluate 2 times tan of negative 5 pi on 4 minus sine of 3 pi on 4. So with these questions, what I like to do, I like to evaluate these two terms here individually. So tan of negative 5 pi on 4 and sine 3 pi on 4, and then substitute them back in. So tan of negative 5 pi on 4 is actually equal to tan of 2 pi take 5 pi on 4, which is in fact tan of 3 pi on 4. If we're using the facts that we just found up here, we actually know that that's negative 1, okay? Now looking at sine of 3 pi on 4, that is 1 on root 2 from above as well. So what we can do now, rewrite the equation that we're trying to solve. Then we're going to just substitute our values in. So 2 times negative 1 minus 1 on root 2. So that there is negative 2 take 1 on root 2. Now doing the cross multiplication method where we put that over 1. All right, so negative 2 times by root 2. Take away 1 times 1 all over 1 times root 2. So we've got negative 2 root 2. Take away 1 divided by the square root of 2. Now, a lot of the times we will get you to rationalize the denominator. When that means, it means getting rid of this surd on the denominator of our fraction. So we do that by multiplying top and bottom by root 2. So this comes out to be negative 4 take root 2 divided by 2. All right. And that is solving 2 times tan of negative 5 pi on 4, take away sine 3 pi on 4. All right, same process should be used for all types of these questions, all right? If you do it systematically, you'll be able to get these questions out, no trouble at all. All right, if you're happy with that, have a crack at 5E at the following questions in the Hazy textbook, and we'll see you guys next time.